Test the polar equation for symmetry. R equals sine of 2 theta. If the point r comma theta is on the graph of the polar equation, then the polar curve is symmetric about the x-axis. If the point r comma theta or negative r comma pi minus theta lies on the graph as well. The graph of the polar curve is symmetric about the y-axis if the point r comma pi minus theta or negative r negative theta lies on the graph. The graph of the polar curve is symmetric about the origin if the point negative r comma theta lies on the graph, or r comma theta plus pi lies on the graph as well, assuming that r comma theta is on the graph. Because of this, to test symmetry about the x-axis in polar coordinate is known as the polar axis. This is the polar axis, the x-axis. We would plug in pi minus theta into the equation to see if we end up with negative r. Sine of 2 times replace theta with pi minus theta. We see that this is sine of 2 pi minus 2 theta, which is sine of negative 2 theta, because 2 pi will skip it. Sine is an odd function, so sine of negative 2 theta is negative sine of 2 theta. What this means is that we end up with a negative r, because r equals sine of 2 theta. Plugging pi minus theta gives us a negative r. What this means is that the graph of r equals sine of 2 theta is symmetric about the polar axis or the x-axis. Similarly, to check symmetric about the y-axis, in polar coordinate, the y-axis is the line theta equals pi over 2. We simply plug in negative theta. Sine of 2 times negative theta is sine of negative 2 theta, which is negative sine of 2 theta, which is negative r. Plugging negative theta gives us negative r, which means the graph of the polar equation r equals sine of 2 theta is also symmetric about the line theta equals pi over 2, or the y-axis. To check if the polar equation is symmetric about the origin is also known as the pole in polar coordinates. We simply plugged in theta plus pi, and if we end up with r, then the graph is symmetric about the origin. So to do that, we plugged in theta plus pi into theta. So this is sine of 2 theta plus 2 pi, which is sine of 2 theta, but sine of 2 theta is r. So yes, when we plug in theta plus pi, we end up with r. What this means is that the graph is symmetric about the origin. And so this curve, whatever it is symmetric about or with respect to the polar axis, which is the x-axis, with respect to the line theta equals pi over 2, which is the y-axis, and about the pole, which is the origin. Knowing these, we only need to graph this graph in the first quadrant, and we would flip or reflect this over the x-axis, the y-axis, or the origin to get the complete graph.